Welcome back, children. Let us move to the worksheet number 3 of kinematics. Here we go with the first question. A body moves with a uniform velocity v1 for some time and with uniform velocity v2 for the next equal time. The average velocity is. Children, as we know the formula for average velocity as total distance upon total time. And here nowhere the distance is being covered, but still let us try to consider the same. So, average speed velocity. Average velocity is given as total displacement to that of the total time. So, let us represent this average velocity as some v equals to total displacement. Let us consider it as total displacement as s1 and s2 and total displacement as total time as t1 and t2. Therefore, the value of average velocity is equals to, so nowhere the value of the displacement is given, children. So, we can write the displacement as, if speed equals to velocity equals to displacement by time, then displacement can be written as velocity into time and time can be written as, so displacement can be written as velocity into time. So, S1 can be written as V1 T1 and S2 can be written as V2 T2. Okay. But here in the question it was given that for some time and next equal time. So, what they are trying to tell us is the value of T1 is equals to T2. Given condition T1 is equals to T2. Let us indicate each time as some T. Let us suppose T1 equals to T and T2 is also equals to T. So, substituting all the values in the above equation, average velocity can be given as V is equals to S1. Instead of S1, let me replace it as V1 T1, V1 T1. This is V2 T2 upon T1 plus T is T plus T. Or average speed is equals to V1. Instead of T1, I have replaced it with a T. And here also V2 T upon T plus T is 2T. All together you have T as common. Take out T as common. Then you are left with this T and T gets cancelled. Then you are left with V1 plus V2 upon 2. So, average velocity is taken as V1 plus V2 by 2. So, first option must be true. Okay. Moving ahead with the second question. A person travelling on a straight line moves with a uniform velocity V1 for a distance x and with a uniform velocity V2 for the next equal distance. Here earlier equal time, now equal distance. The average velocity is given by. So, same like previous problem. So, average velocity can be given as total displacement to that of total time. So, average velocity let us indicate with the letter V and total displacement in general we consider only two conditions. So, S1 plus S2 upon T1 plus T2. Okay, but here nowhere the value of time is mentioned, so you have to eliminate time, and from our formula speed equals to velocity equals to displacement by time. Time can be written as displacement by velocity. So, this implies T1 is equals to S1 by V1 and T2 is equals to S2 by V2. Substituting the values in the above equation, we have average velocity equals to S1 can be written as speed into time. S1 straight line moves with a uniform velocity for a distance x they have given. The value of S1 is given as x plus and with the uniform velocity v2 for the next equal distance. If earlier if it is considered x, next also you have to consider it as x. S1 is x and S2 is also equals to x upon T1. Instead of T1, I have to replace it with S1 by V1 and T2 should be replaced with S2 by V2. Therefore, average velocity is given as x plus x is 2x. S1, first distance is x. First velocity as V1, next distance as x, next velocity as V2. This implies both we have x as common. So, we have v can be written as 2x upon, if x is taken common, you are be left over with 1 by v1 plus 1 by v2. So, simplifying further, this x and x gets cancelled. Let us bring this 1 by v1 plus 1 by v2 this side and v to the other side. Then we have, bringing this bracket other way, 1 by v1 plus 1 by v2 is equals to, bringing this v down, we have 2 by v. So, clearly we can see that 2 by v is equals to 1 by v1 plus 1 by v2. Hence, the third option must be true. That is, 2 by v is equals to 1 by v1 plus 1 by v2. So, moving ahead with the next one, third question. Consider the motion of the tip of the minute hand of a clock. So, you are asked to visualize the motion of a tip of a clock. So, something like this. A clock is being given and tip of the minute hand of a clock in 1 hour more than one. Okay, in 1 hour the displacement is. So, actually 1 hour what you observe is that this like this, like this, like this, it moves. Okay, and somehow it travels like this and again it reaches back to the initial position. So, 1 hour the minute hand makes a complete circle. Whenever it makes a complete circle, then it comes to the same initial, the final position is equals to the initial position. When initial position and final position are same, the displacement is 0. So, this clearly indicates that displacement is 0. But distance is 2 pi r. The displacement is 0. Yes, of course. But here in the bracket it was given that more than one answer is possible. Of course, first is true. Let us also check whether another correct answer is also there. The distance, is the distance covered 0? No. It depends upon, it's equals to 2 pi r. So, where r is the radius. So, some value will be getting. Average speed. When distance is not equals to 0, speed is also not equals to 0. It has some speed given by distance upon time. So, this is also wrong. Average velocity is 0. Yes, of course, children, average velocity equals to total displacement by total displacement to that of the total time taken. So, what is the total displacement which we have just calculated? 0. So, 0 by some time is nothing but 0. So, average velocity can also be 0. So, whenever displacement is 0, then velocity is also 0. Whenever speed is non-zero, whenever distance is non-zero, speed is also non-zero. So, what is the correct option? You have two correct options for this answer, children. One is first option is true, as well as third one is, as well as fourth one is also true. Two options are correct. So, moving ahead with the next one, fourth question. Mark the correct statements. The magnitude of the velocity of a particle is equals to its speed. Magnitude of velocity. So, where direction is not considered, only the magnitude of velocity is considered. Of course, magnitude of velocity is nothing but speed. So, as we know that, magnitude of distance is displacement. Magnitude of displacement gives a distance, whereas the magnitude of velocity gives speed. So, of course, the first one is true. Because magnitude indicates only the numerical value, and apart from that, velocity has magnitude numerical value along with some direction. Speed only magnitude. Okay. Magnitude of average velocity in an interval is equals to the average speed in that interval. So magnitude of an average velocity in particular interval it was given that. So it cannot be. So overall we always consider children. So particular interval we can't say anything. It is possible to have a situation in which the speed of a particle is always 0 but average speed is not 0. So as we know that displacement can be 0, negative or positive, but distance is never 0. So distance upon time speed can never be 0, whereas velocity can be 0. Okay, so this is also a wrong statement. It is possible to have a situation in which the speed of the particle is never 0, but the average speed in an interval can also be 0. So no, this is also not possible. One particular, if only all are 0, then only everything will be 0. A particular case is not possible. So only correct option from this is option 1. So moving ahead with the next question, fifth one children, there is a square field of side A units. So what is given? A square field is given and each side is given as A. An insect starts from one corner, an insect starts from one corner and reaches the diagonally opposite corner in time. So starts here and again reaches diagonally opposite in this particular direction. The magnitude of average velocity is, children, as we know that average velocity is nothing but the total displacement to that of total time. So what is the total displacement? If this is A and this happens to be a right angle triangle, the total displacement is given as sum of the squares of the other two sides, that is root over A square plus A square. Okay, so this is equals to root over A square plus A square whole upon some time interval T. In some time T, and this is found to be root over A square plus A square is equals to root over 2A square upon T. So if average velocity is equals to root over 2A square by T, then root 2 over A square is nothing but root over A square is A root 2 upon T. So average velocity is found to be A root 2 upon T or root 2A upon T. So first option must be true. That's it children. So total displacement to that of total time taken.